Now, let's talk about switch security configuration, chapter 11. The overview of this, the module objective configures switch security to mitigate LAN attacks. Topic titles, implement port security, which implement port security to mitigate MAC address table attacks, mitigate VLAN attacks, explain how to configure DTP and the native VLAN to mitigate VLAN attacks. Then mitigate DHCP attacks. Explain how to configure DHCP snooping to mitigate DHCP attacks. Mitigate ARP attacks. Explain how to configure ARP inspection to mitigate ARP attacks. Then mitigate STP attacks. Explain how to configure port pass and BPD guard to mitigate STP attack. Then next, let's go to the next one. The implement port security. Implement port security, there is the secure unused port, mitigate MAC address table attacks, enable port security, limit and learn MAC addresses, port security aging, port security violation modes, person error disable state, then verify port security. In secure unused ports, layer 2 devices are considered to be the weakest link in the company's security infrastructure. Layer 2 attacks are some of the easiest for hackers to deploy, but these threats can also be mitigated with some common Layer 2 solutions. All switch ports interfaces should be secured before the switch is deployed for production use. How a port is secured depends on its function, and a simple method that many administrators use to help secure the network from unauthorized access to disable all unused ports on a switch. For example, the Catalyst 2960 switch has 24 ports. There are 3 capacitor net connections in use. It is good to practice to disable the 21 unused ports. Navigate to each unused port and issue the Cisco IOS shutdown command. If port must be reactivated at a later time, it can be enabled with the no shutdown command. Then, the mitigate MAC address table attacks. The simplest and most effective method to prevent MAC address table overflow attack is to enable port security. Port security limits the number of valid MAC addresses allowed on a port. It allows an administrator to manually configure MAC addresses for a port or two, permit the switch to dynamically learn a limited number of MAC addresses. When a port configured with port security receives a frame, the source MAC address of the frame is compared to the list of secure source MAC addresses that were manually configured dynamically learned on the port. By limiting the number of permitted MAC addresses on a port to 1, port security can be used to control unauthorized access to the network. Then, the enable port security. The switch port security command was rejected. This is because port security can only be configured on manually configured access ports or manually configured trunk ports. By default, layer 2 switch ports are set to dynamic auto-trunking. Then, the limit and learn MAC addresses. To set the maximum number of MAC addresses allowed on the port, use switch port security maximum value. Or 1. Manually configure. The administrator manually configures static MAC addresses by using the following command for each secure MAC address on the port. The switch port security MAC address address the dynamically learned when the switch port command is entered. The current source MAC address for the devices connected to the port is automatically secured but is not added to the startup configuration. If the switch is rebooted, the port will be had to relearn the device MAC address. Dynamically learn sticky. The administrator can enable the switch to dynamically learn the MAC address and stick then the running configuration by using the following command, which is switch port security MAC address sticky. Saving the running configuration will commit the dynamically learn MAC address to the NVRAM. Then the port security aging. Port security aging can be used to set the aging time for a static and dynamic secure address on a port. Two types of aging are supported per port. The absolute, which is the secure address on the port are deleted after the specified aging time. In the inactivity, the secure addresses on the port are deleted only if they are inactive for the specified aging time. Use aging to remove secure MAC address on a secure port without manually deleting the existing secure MAC addresses. Aging time limits can also be increased to ensure past secure MAC addresses remain, even while new MAC addresses are added. Aging of statically configured secure addresses can be enabled or disabled in a per port basis. Then, let's go to port security violation modes. If the MAC address of a device attached to the ports differ from the list of secure addresses, then a port violation occurs by default. The port enters the error disabled state. To set the port security violation mode, we use the switch port, the security violation, then bracket, protect, then the line restrict, shutdown, security violation mode description. In shutdown, which is the default, the port the error disabled state immediately turns off the port LED and sends a log message. It increments the violation counter when the secure port is in the error disabled state. An administrator must re-enable it by entering the shutdown and no-shutdown commands. Then the restrict mode, the port drops packets with a known source address until you remove a sufficient number of secure MAC addresses to drop below the maximum value or increase the maximum value. This mode causes the security violation counter to increment and generate a system log message. Then the protect mode, this is the least secure of security violation modes. The port drop packets with unknown MAC source addresses until you remove a sufficient number of secure MAC addresses to drop below the maximum value or increase the maximum value. No system log message is sent. Then, in security violation mode comparison, in protect violation mode, there are discards of pending traffic. Then in restrict mode, it has discards of pending traffic too. Then sends its log message and increased violation counter. And the shutdown has discards of pending traffic, sends its log message, increased violation counter, and shutdown port. Then the port in error disabled state. When a port is shut down and placed in the error disabled state, no traffic is sent or received on the port. Series of port security related messages display on the console. Then verify port security. After configuring port security on a switch, check each interface to verify that port security is set correctly and check to ensure that the static MAC addresses have been configured correctly. Then let's go to the next one, which is mitigate VLAN attacks. The VLAN attacks review. As a quick review, a VLAN hopping attack can be launched in one of three ways. Spoofing DTP messages from the attacking host to cause the switch to enter tracking mode. From here, the attacker can send traffic tagged with the target VLAN. The switch then delivers the packets to the destinations. Introducing a rogue switch and enabling trunking, the attacker can then access all the VLANs of the victim switch from the rogue switch. Then another type of VLAN hopping attack is the double tagging or double encapsulated attack. This attack takes advantage of the way hardware on most switches operate. Then, steps to mitigate VLAN hopping attacks. Disable DTP or auto-trunking negotiations on non-trunking parts by using the switch port mode access interface configuration command. Then the next step, disable the unused ports and put them in an unused VLAN. Then the next step, manually enable the trunk link on the trunking port by using the switch port mode trunk command. Then step 4, disable DTP auto trunking negotiations on trunking ports by using the switch port no negotiate command. Then the step 5, set the native VLAN to VLAN other than VLAN 1 by using the switch port trunk native VLAN. For example, then let's go to the next, which is the mitigate DHCP attacks. DHCP attack review. The goal of a DHCP starvation attack is to create a denial of service, or what we call DOS or DOS. For connecting clients, DHCP starvation attacks require an attack tool for such as Gobbler. Recall that DHCP starvation can be effectively mitigated by using port security, because Gobbler uses a unique source MAC address for each DHCP request sent. However, mitigating the HCP spoofing attack requires more protection. Gobbler can be configured to use the actual interface MAC address as the source Ethernet address, but specify a different Ethernet address in the DHCP payload. This would render port security ineffective because the source MAC address would be legitimate. Then DHCP spoofing attacks can be mitigated by using DHCP snooping on trusted ports. Then let's go with DHCP snooping. DHCP snooping does not rely on source MAC addresses. Instead, DHCP snooping determines whether DHCP messages are from an administratively configured trusted or untrusted source. It then filters DHCP messages and rate limits DHCP traffic from untrusted sources. Devices under your administrative control, such as switches, routers, and servers, are trusted sources. Any device beyond the firewall or outside your network is an untrusted source. In addition, all access ports are generally treated as untrusted sources. A DHCP table is built that includes the source MAC address of a device, an untrusted port, and the IP address assigned by the DHCP server to that device. The MAC address and IP address are bound together. Therefore, this table is called the DHCP snooping binding table. Then let's go to steps to implement DHCP snooping. Step 1. Enable DHCP snooping by using the IP DHCP snooping or global configuration command. In the next step, on trusted ports, use the IP DHCP snooping trust interface configuration command. Then limit the number of DHCP discovery messages that can be received per second on untrusted ports by using the IP DHCP snooping limit rate interface configuration command. Then lastly, enable DHCP snooping by a range of VLANs by using the IP DHCP snooping VLAN global configuration command. Then let's go to the next, which is mitigate ARP attacks. Dynamic ARP inspection. In a typical ARP attack, a threat actor can send unsolicited ARP replies to other hosts on the subnet with the MAC address of the threat actor and the IP address. To prevent ARP spoofing and the resulting ARP poisoning, a switch must ensure that only valid ARP requests and replies are relayed. Dynamic ARP inspection, or DII, requires DHCP snooping and helps prevent ARP attacks by not relaying invalid or gratuitous ARP replies out to the ports in the same VLAN, then by intercepting all ARP requests and replies on untrusted ports, and by verifying each intercepted packet for a valid IP to MAC binding, then by dropping and logging ARP replies coming from invalid to prevent ARP poisoning, and by error disabling the interface if the configured DII number of ARP packets is exceeded. Then DII implementation guidelines. To mitigate the chances of ARP spoofing and ARP poisoning, follow these DII implementation guidelines. First one is enable DHCP snooping globally. The second one is enable DHCP snooping on selected VLANs. Then enable DII on selected VLANs. Then lastly is to configure trusted interfaces for DHCP snooping and ARP inspection. It is generally advisable to configure all access switch ports as untrusted and to configure all uplink ports that are connected to other switches as trusted. Then let's go to the last one, which is mitigate STP attacks. Port pass and BPD word. Recall that network attackers can manipulate the spanning tree protocol or the STP to conduct an attack by spoofing the root bridge and changing the topology of a network to mitigate spanning tree protocol or STP manipulation attacks. Use port pass and bridge protocol data unit or BPDU guard. The port pass. It immediately brings an interface configured as an access or trunk port to forwarding state from a blocking state, bypassing the listening and learning states. Apply to all end users. Port pass should only be configured on port attached to end devices. BPDU guard. The BPDU guard immediately error disables a port that receives a BPDU like port pass. BPDU guard should only be configured on interfaces attached to end devices. Then configure port pass. Port pass bypass the STP listening and learning states to minimize the time that access ports must wait for STP to converge. If port pass is enabled in a port connecting to another switch, there is a risk of creating a spanning tree loop. Port pass can be enabled and interfaced by using the spanning the tree port pass interface configuration command. Alternatively, port pass can be configured globally on all access ports by using the spanning the tree port pass default global configuration command. To verify whether port pass is enabled globally, you can use either the show running -config pipe begin span command or the show spanning the tree summary command. To verify if port pass is enabled on interface, use the show running -config interface, type /number command. It's known in the following. Then configure the BPD guard. Even though port pass is enabled, the interface will listen for BPD use. Unexpected BPDs might be accidental or part of an unauthorized attempt to add a switch to the network. If any BPDs are received on a BPD guard enabled port, that port is put into error disabled state. This means the port is shut down and must be manually enabled or automatically recovered through the disable recovery cost secure _violation global command. Then BPD guard can be enabled in a port by using the spanning -3 BPD guard enable interface configuration command. Alternatively, use the spanning -3 port pass BPDU guard default global configuration command to globally enable BPDU guard on all port pass enabled ports. Then that will conclude all the chapter 11, which is the switch security configuration.